UL508A Section 31.4.3 addresses the ampacity of tap conductors and internal conductors to individual loads. Internal conductors are defined as the conductors located within the enclosure or assembly that serve to connect the tap conductors to the individual loads. To understand this, consider a control panel. Tap conductors are those that branch off from a main feed circuit to supply power to a specific section or component within the panel. These tap conductors typically land on a terminal block or other connection point inside the enclosure. From that connection point, internal conductors then carry the current to the individual loads, such as a motor starter, a programmable logic controller, a power supply, or any other device requiring electrical power. The requirement regarding the ampacity of these internal conductors is crucial for ensuring safety and preventing overheating. The National Electrical Code, or NEC, plays a significant role in determining the appropriate ampacity for conductors. Several NEC articles and tables are relevant in this context. Firstly, NEC Article 310 provides general requirements for conductors for general wiring. Secondly, NEC Table 310.16, which is now 310.15b16 in newer editions of the NEC, specifies the allowable ampacities of insulated conductors rated up to 600 volts, not more than 3 conductors in a raceway or cable or earth, based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. Adjustments must be made to these ampacity values for ambient temperatures other than 30 degrees Celsius and for situations where there are more than 3 current-carrying conductors in a raceway or cable. These adjustment factors are found in NEC Table 310.15 cone, which was formerly Table 310.15b3. The ampacity of the internal conductors must be sufficient to carry the load current safely without exceeding their temperature rating. The ampacity is determined by the size of the conductor, its insulation type, and the ambient temperature in which it is installed. For example, a 14 American wire gauge or OG copper conductor with a type THHN insulation might have an ampacity of 20 amps at 30 degrees Celsius, according to NEC Table 310.15b16. However, if the ambient temperature is higher, or if there are more than 3 current-carrying conductors in the raceway, this ampacity must be reduced using the correction factors in NEC Table 310.15 cone. UL508A provides specific guidelines for conductor sizing within industrial control panels, often referencing the NEC. Section 28 and Section 31 of UL508A deal with wiring methods and conductor requirements. It is crucial to consult these sections in conjunction with the NEC to ensure compliance. The goal is to select internal conductors with an ampacity equal to or greater than the calculated load current. The load current should include any applicable safety factors as specified in UL508A or the NEC. Moreover, the voltage drop across the internal conductors must be considered. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. The length of the internal conductors, the conductor size, and the load current all influence voltage drop. It's important to calculate voltage drop using appropriate formulas or software tools to ensure that it remains within acceptable limits. In summary, when dealing with internal conductors in a control panel according to UL508A, firstly, identify the tap conductors and the individual loads they supply. Secondly, determine the load current for each individual load, including any applicable safety factors. Thirdly, select internal conductors with an ampacity equal to or greater than the calculated load current, taking into account the conductor's insulation type, ambient temperature, and the number of current-carrying conductors in the raceway or cable. Fourthly, calculate the voltage drop across the internal conductors and ensure that it remains within acceptable limits. Fifthly, consult NEC Articles 310 and UL508A Sections 28 and 31 for specific requirements and guidelines. By following these steps, one can ensure that the internal conductors within a control panel are properly sized and installed, contributing to the safe and reliable operation of the equipment. Proper conductor sizing is a fundamental aspect of electrical safety. Undersized conductors can overheat, leading to insulation failure, short circuits, and potentially fires. Oversized conductors, while not posing an immediate safety hazard, can increase material costs and take up valuable space within the control panel. Therefore, selecting the correct conductor size is essential for both safety and cost effectiveness. The choice of conductor material, typically copper or aluminum, also affects ampacity. Copper conductors generally have a higher ampacity for a given size compared to aluminum conductors. However, aluminum conductors are lighter and less expensive, making them suitable for certain applications. When using aluminum conductors, it's important to use connectors and termination methods specifically designed for aluminum to prevent corrosion and ensure a reliable connection. The type of insulation used on the internal conductors also plays a crucial role in determining their ampacity and suitability for different environments. Common insulation types include THHN, THWN, and XHHW. Each insulation type has different temperature ratings and resistance to moisture, chemicals, and abrasion. The selection of the appropriate insulation type depends on the specific conditions within the control panel and the surrounding environment. For example, in a damp or wet location, a conductor with THWN insulation would be more suitable than one with THHN insulation. Furthermore, the routing and bundling of internal conductors can affect their ampacity. When conductors are bundled together, they generate heat, which can reduce their ampacity. The NEC provides guidelines for determining the ampacity of conductors based on the number of current-carrying conductors in a raceway or cable bundle. It's essential to follow these guidelines to prevent overheating and ensure the safe operation of the control panel. Proper labeling and identification of internal conductors is also important for maintenance and troubleshooting purposes. Each conductor should be clearly labeled with its circuit designation and function. This helps electricians and technicians quickly identify and trace conductors, reducing the risk of errors during maintenance or repairs. In addition to ampacity, it is also important to consider the short circuit current rating of the internal conductors and the control panel components. The short circuit current rating is the maximum current that a component or conductor can safely withstand during a short circuit fault. The control panel and its components must be able to withstand the available short circuit current at the point of installation. This is typically determined by the utility company or a qualified electrical engineer. Fuses, circuit breakers, and other overcurrent protection devices are used to protect the internal conductors and components from damage during a short circuit. These devices must be properly sized and coordinated to ensure that they trip quickly and safely interrupt the fault current. Coordination studies are often performed to determine the optimal settings for overcurrent protection devices. These studies take into account the characteristics of the electrical system, the available fault current, and the ratings of the components. Another consideration is the grounding and bonding of the control panel and its internal components. Grounding provides a low impedance path for fault current to flow back to the source, helping to trip overcurrent protection devices quickly and safely. Bonding ensures that all metal parts of the control panel are electrically connected, minimizing the risk of electric shock. The NEC provides detailed requirements for grounding and bonding, which must be followed to ensure electrical safety. Regular inspection and maintenance of the control panel and its internal conductors is essential for preventing problems and ensuring continued safe operation. Inspections should include checking for loose connections, damaged insulation, and signs of overheating. Any problem should be corrected promptly to prevent more serious issues from developing. Maintenance tasks may include tightening connections, replacing damaged conductors, and cleaning the inside of the control panel. Keeping the control panel clean and free of dust and debris helps to prevent overheating and other problems. The UL508A standard and the NEC are constantly evolving to reflect changes in technology and best practices. It's important to stay up to date on the latest requirements and guidelines to ensure that control panels are designed, installed, and maintained safely and effectively. This may involve attending training courses, reading industry publications, and consulting with qualified electrical engineers. In conclusion, the ampacity of internal conductors within a UL508A control panel is a critical factor in ensuring electrical safety and reliability. Understanding the requirements of UL508A and the NEC, selecting appropriate conductors and insulation, calculating voltage drop, and implementing proper grounding and bonding practices are all essential for creating a safe and effective control panel. Remember to always consult with qualified electrical professionals for specific applications and to ensure compliance with all applicable codes and standards. By paying close attention to these details, one can help prevent electrical hazards and ensure the long-term performance of the control panel.